Somehow, I became in charge of building props for my kids' high school marching band this year. I really need to start paying more attention in those meetings. At least I know exactly where to start, and that was deciding what new tool I wanted. That way I could make sure the project required those tools. I knew I wanted a welder, so you can bet we were going to use metal in this project. And since there was going to be metal, sparks, and fire, I needed a crack team of band dads that were dedicated to seeing the project through to completion without burning down my garage. And not causing too much bodily harm to each other. Let's see, what else do we need to know? Oh yeah, what are we actually going to build? The theme of the marching show this year was seraph. The first thing that comes to mind when I think of seraph is, what? After a little Googling and team collaboration, the next thing that comes to mind is angel wings and lyres. And I mean really big ones. After all, we're in Texas, so let's make them as big as we can. I'm thinking like 20 feet tall. We can't do 20 feet? I'm told 12 feet is the max allowed height. Well, there's our first project constraint. Anything else we need to consider for this project? We have an unlimited budget, right, for supplies? And to bring in special consultants as we need? Okay, the budget is tight. We need 7 of these, 12 feet tall, easy enough for the kids to move them on and off the field fast, be able to rotate them during the performance, and transport them in a single Penske box truck. So we're good if I design them for the height of a Penske box truck, right? I mean, we have a Penske box truck for each time we need to transport these props. Like one week you won't show up with a U-Haul that is 6 inches too short for the props to fit into the truck. So we have to have Brian take the 80-pound concrete counterweights off each prop and hand lift them into the truck. We are good, right, Dennis? How do you build a 12-foot lyre? I had no clue, so it seemed the best place to start is with a half-scale prototype. My wife was a big help in this project. We started by tracing the projection of a lyre on some foam. This seemed like a good idea, but in reality, hand tracing didn't look all that good, and cutting with a hot wire by hand just compounded the inconsistencies. What we did learn from the prototype was that using rigid foam board insulation would be a good idea, but we needed a better, more repeatable way of cutting our parts from it. We also learned that using spray adhesive was way too messy and not a good choice for gluing the foam layers together. Gorilla Glue turned out to be great for this task. It held very well and was less messy to apply. How could we mass produce all the foam pieces that we needed, 98 pieces in total, that is very repeatable and fast to make? Having experience with laser cutters, 3D printers, and CNC, my mind goes to how can we use one of them to somehow digitally fabricate the parts we need. The struggle is that we are talking about making pieces that are over 8 feet long. Right away, laser cutting and 3D printing seemed impractical, at least using the ones that I have. CNC seems feasible, but again, mine is too small for this job. But I bet I could find a larger one in the Dallas area that I could use. I discovered a really cool makerspace in Dallas called the Workshop by TBK Bank. Not only did they have a CNC that could handle 4x8 foot sheets material, it also made for a great field trip for my youngest son. But we're getting ahead of ourselves. We now know we have access to a large CNC, but what do we do with it? It still wasn't practical to haul all my material to the makerspace and cut 98 pieces out. Here's what a load of foam just for one prop looks like in my truck, let alone 7 props worth. I wanted a way we could cut all the pieces at the high school during a props workday. This would allow us to have Home Depot deliver all the foam at once. And by having other band parents help out, we should be able to multiply our efforts of getting all the pieces cut quickly. It will take some planning though to achieve this efficiency. And that brings us back to the problem of how to define a repeatable and simple process for cutting all the foam pieces we need. The solution is making templates that when combined with a compact router can produce exact copies of our parts. We can use the large CNC to digitally fabricate a set of templates and then use those templates as the guide when cutting the foam with the router. We can take a file straight from the computer to the CNC to digitally create our master template. And then with the guide bushing on our router, just hold the router against the edge of the template and cut. And by having multiple templates and routers, we can cut multiple parts at the same time, speeding up the process. Taking the image that the band director sent me, I was able to use Paint.net and Inkscape to create a vector file of the wings and lyre. Now with these vector files, it was time to open Fusion 360 and start designing a full-size prop. I've been using Fusion 360 for a few years now. I started using it when I got my CNC, as it was my choice of software for creating G-code. This is by far the largest project I have modeled, and it was very helpful to be able to model the full prop in Fusion, as it allowed me to play around with a couple different ideas and also generate images to share with others to get feedback. I spent many nights designing out the prop in Fusion 360, and the time was well spent, as I used the CAD models as references many times throughout the project. I was able to design the prop to actual scale and slice them into parts. The final design has the wings almost 10 feet from top to bottom and about 2 feet off the ground to give us a 12-foot tall prop. And the lyre is 8 feet wide and 10 feet tall. The foam we were using comes in 4 by 8 foot sheets, so I knew the wings and lyres were going to have to be made from multiple pieces. Plus, to make them easier to haul, we wanted them to come apart. Using Fusion 360, I worked out the best way to divide the wing and lyres into parts to maximize the use of the foam sheets. Once this was figured out, I could export my G-code for the CNC and cut some templates. Since the wings are symmetrical, I just needed one template for each unique part, as the templates could be flipped. And for the lyre, we just needed the bottom piece and one top, since the tops were symmetrical. A total of 4 templates to make 7 parts of wings and lyres. We have our design for the wings and lyre. We now need to design some frames to hold them. And because a few years ago, we built some behemoth props out of 2x6s and plywood, which weighed a ton, I wanted to make this year's frames out of 1-inch square metal tubing instead of wood. I figured it would be much lighter with the same strength and can be reused in future years, unlike the wood frames. And remember, I have to justify the welder to my wife. The frames needed to hold the wings and lyres, roll on the turf easy, and come apart to fit compactly into a box truck. This all led me to design a square base that is wide as I could make it, but still fit 2 of them side by side in a box truck, and a center vertical frame that is 12 feet from its top to the ground that could hold the wings, lyres, and cloud backdrop. And this frame would be made into 2 pieces, so one could remain on the base and still be short enough to clear the door opening of the box truck. This was a lesson learned from previous year's props, where we didn't measure the door opening of the truck and the props were just 1 inch too tall to fit. I mean, literally just 1 inch. I swore that I would not make that mistake again. So this year, I personally measured the door opening of a Penske box truck and made sure to design the frames to be short enough to fit. But yet again, fate would have it that I need to learn another lesson. And that lesson was not to count on being able to rent a Penske truck in the middle of a pandemic-induced supply chain crisis. For our first contest, we had a Penske, and everything loaded and unloaded so nicely. But for the next contest, there were no Penske trucks to be found, so we were forced to rent a U-Haul truck that had a lower door opening, making it a pain to load and unload the props. So lesson learned, future props need to be designed to fit inside a minivan just to be safe. Knowing that the wings and lyre are going to be tall and wide, I decided to rotate the base 45 degrees to make the vertical support wider, and to give a little larger footprint from the front to back for the base. After testing the frame with a set of wings and lyres, it became obvious that there needed to be handles on the side to help move and rotate the props. The handles and top pieces were designed to be removable to allow the frames to fit into the truck. To speed up assembly during contests, we welded capture nuts for these parts. This reduced the number of tools needed for tightening and loosening the bolts. I thought a good way to attach or hang the wings and lyres to the frame was with hooks and magnets. I would attach a hook to the top of each foam piece and would align it with a hole drilled into the metal frame, and then add magnets to the foam below the hooks as additional hold points. It seemed like a good idea. You would just lift the foam piece into place, align the hook, and hang it. The magnets would then snap to the metal and hold it in place. At least that was the theory, and it worked well in my small scale test, but the magnets were not strong enough to hold the full-size pieces. The hooks did work well. By gluing 3-inch dowels into the foam, this made a very secure attachment for the hooks to screw into. One drawback of this method was that at times it could be a bit of a challenge to line up the hooks to the holes in the frame. Around the second contest, a better idea for attaching the foam to the frame came to me, but at this point there was no value in changing the design. Luck would have it though, the Winter Guard decided to use a pair of wings for their contest, so this gave me a chance to try out my new design idea. I cover it in another video. Another design goal was to have all the foam pieces and frame parts that come off for hauling stack on the base frame for easy transport. I partially achieved this goal. The wings and top parts of the lyre could fit onto the base and be held in place with some PVC and bungee cord. The lyre bottom and strings though would not fit onto the base. Everything did fit into a single truck with a little room to spare. Once all the welding was done, all the metal got a coat of primer and then painted black. Let's just say my garage had a lovely spray paint smell for days. And since the frames were built like an IKEA flat pack, I was able to haul all 7 in the back of my truck to the high school for final assembly. To help align the wings and lyre parts when assembled, we added indexing pins in the form of dowels and PVC. By gluing the PVC into the foam, it allowed for the dowels to be inserted and removed as needed, without the foam wearing over time. An interesting side note though, Wood swells when it gets wet. At our first contest, it poured just as the kids took the field. I was thinking the props would be fine getting wet since they are made from metal and foam, but I didn't think about those wood dowels. When we disassembled the props that day, we discovered that some of the dowels got soaked from the rain and swelled enough to be jammed in the PVC, causing PVC to be ripped out of the foam. Final part of the lyres were to add strings. We wanted 7 strings per lyre, and a 1-inch diameter PVC pipe about 80 inches long was the correct scale for a single string. Adding a strip of plywood at the top and bottom of PVC made the strings a single unit for assembly and also held them in place by snugly fitting into slots in the foam. A lesson learned here was it would have been a lot easier to paint the PVC after it was assembled than as individual pieces. Now that we had all the parts and pieces made, it was finally time to fully assemble our first prop. This was an awesome moment to see all the planning and building come together, and it was short-lived thanks to the wind. Once we had the wings and lyres on the frame and there was 10 to 15 mile/hour wind, it became obvious that I did an awesome job of making these frames really light. You might say too light. They moved so well that the wind had no problem pushing them around, and the wind didn't care if we chalked the wheels to stop them from rolling. It still kept pushing. As much as I didn't want to add more weight, it was clear we had to do something to counter the wind's effect. I needed to find a lot of cheap weight that I could add to the bases to lower the center of gravity, to reduce the chance of the props tipping over. After a quick trip to Home Depot, $5 bags of 80-pound cement mix seemed like a solution. For a quick test, I purchased 2 bags just to sit on the frames, and that appeared to be a solution. Now it was a matter of making the concrete blend into the props. 14 wooden forms are made to hold a 2-inch thick pour of concrete. Renting the cement mixture is worth every penny when you have 14 bags to mix. And just like that, the frames gained 160 pounds and were still very maneuverable. The extra weight worked well to counterbalance the wind's effect. I love these 2 images. This one is the mock-up drawing when we were still brainstorming prop ideas for the marching show. And this one is a photo taken at one of the contests. To have the real project turn out almost picture perfect to the planned drawing is so cool to me. Overall, I think the project turned out great. I came in about 30% under budget and feel the frames are an investment in the program because they could be reused in the future. And we never had a prop blow over or come apart. Now I wonder what challenges lay ahead for next year's props. It all starts again in about 4 months. And with 2 more kids in band, I have 5 more years as a band dad for a grand total of 10 years. That's it, that's awesome, that's the video. Hit the subscribe button. And a quick thanks to the guys at Metal Supermarket in Lewisville. They were a big help and time saver with drilling many of the holes and cutting all of my parts to length. And check out my other Maker Play videos.